Hello students, there is another video, solutions to problems 11 and 12 from your final exams in structural theory just this December 2023. So 11, by moment distribution method, determine the vertical reaction at C. EI is constant. So first, let's compute for fixed moments at each segment of the beam. By the way, DE is transformed into, so the moment due to 20 kilonewton load is 20 times 1, so it is 20 as shown, and the 20 kilonewton load is transferred at D. So we imagine that the end support is a ruler, and we have 20 kilonewton here, and the couple applied 20 kilonewton meter. Now, because we only have CD, D is the end support. So take note, D is the end support. So we have to modify the stiffness. The stiffness of AB is modified because the moment at A is 0. So 3/4 of I over L. 3/4 of I, we consider I as 1 over L, which is 6 because EI is constant. So 1/8. BC, interior support, so it is just 1 over the span, 1 over 8. CD, take note, it is up to D. So we modify the stiffness by multiplying 3/4 of I, which is 1 over the span 4. So it is 3 over 16. So these are now the distribution factors at A, because there's only one member attached and it is a pin. By experience, it is 1, but we make it -1. My suggestion, so that you will not forget to change the sign after distributing the unbalanced moment at each joint. Then 1/8 divided by quantity 1/8 plus 1/8, so it is 1/2, or we make it -1/2, so -0.5, -0.5, -0.5. CB, 1/8 divided by 1/8 plus 3 over 16, and that is 2/5, or make it -0.4, so the other end -0.6, because the sum is supposed to be 1. Then at D, it is -1, because as I said, we have to transform this into a ruler with the reaction with a 20 kilonewton load applied over D, so it will not cause moment anymore, and this couple, which is equal to 20 kilonewton meter, which is uh, negative in DE. So negative in DE. Then we compute fixed moments. Fixed moment at AB equals fixed moment BA because the couple acts at the center. The formula is MB over L square quantity 2L minus 3B. So M, 90, positive 90 because this is clockwise. B is 3, distance of couple from right, over L square over 6 square quantity 2L minus 3 times B. So it is also equal to fixed moment BA. So it is 22.5. The sign is positive, so that's why it's also positive here. Then for BC, fixed moment BC, WL square over 30, negative here. So fixed moment BC is negative. I'm not showing the value, the formula rather, but it is negative W, negative 45, 8 square over 30, and it is negative 96. CB, on the other hand, is positive W, positive 45, 8 square over 20. Check with your calculator, 144. Moment CD, because the uniform load is not acting on the entire span, we have to apply integration. So we have the strip here. I call this X. So therefore, it is the negative of integral of dp, which is height of strip 45 dx, times ab square. So x, then 4 minus x quantity square, x, 4 minus x quantity square, differential p AB square all over L square, span is 4 square. Limits of x would be 0 to 3 only. 0 to 3, so it's negative 56.953. This one. Then finally, fixed moment DC is the positive of integral. Interchange the squared terms. This time x is squared, 4 minus x raised to 1 over 4 square, same limits. So 44.297. So the next step, so these are the fixed moments. We write it here, the first row. Next is we distribute. So negative 22.5 times negative 1 is, of course, negative 22.5. Then we lock it finally because we know that the moment that A is 0. Final. Then, unbalanced moment at B is quantity 22.5 times negative minus 96 close times negative zero point 0.5. So 36.75 also here because the distribution factor is the same. Here at C, quantity 144 minus 56.953 close times negative zero point 0.4. So negative 34.819. Replace 0.4 by 0.6. So negative 52.228. Then finally at D, quantity 44.297 minus 20 times negative 1 is negative 24.297. And we lock it also finally because the moment D is negative 20, moment DC is definitely positive 20 by adding this. So that's positive 20, negative 20 on DE. So 20, negative 20, that's finalized. Next is carry over. So half of negative 22.5 is negative 11.25. We do not carry over half of 36.75 anymore because we lock this finally. That's the hint. So anyway, this is final 0 moment. Then half of negative 34.819 is this, negative 17.410. Half of 36.75 is that. Then half of negative 24.297, then we don't need to carry over half of negative 52.228 here because this is already finally locked. After that, we distribute again quantity at B, quantity negative 11.25 plus negative 17.41 times negative zero point 0.5 is 14.330. So also 14.330 here, same distribution factor. Here, quantity 18.375 minus 12.148 times negative zero point 0.4. So this is the result, negative 2.491. And replace 0.4 by 0.6. This is the result, negative 3.736. Then carry over. So none here because there's no more moment here. And half of negative 2.491 is negative 1.246. Half of 14.330 is 7.165. Then no more here because there's no moment from there. Then that's the second cycle, third cycle, fourth cycle, fifth cycle, until such time that the distributed moment is less than absolute value of 0.1, or distributed absolute value of distributed moment is less than 0.1. So that's why you just verify this, pause the video until such time that you arrive with this value here. These are now negligible, so we lock them finally. So this is the final moment in kilonewton meter. Adding this column rather, 63.736, adding this row, negative 63.737, there's a discrepancy of 0.001. That's tolerable. So that means the calculations, the tabulations are correct. Here it's 129.776. On the right side, negative 129.776. So same. So meaning the moment at B is negative 63.737, at C negative 129.776. We then apply these moments counterclockwise at B, C, then clockwise at CB, counterclockwise at for C to D, or moment at C. Since it is reaction at C that is needed, so considering BC, I'll call this RC left, summation moment B equals 0, RC left times 8 plus 63.737 equals 129.776 plus the moment of the triangular load 1/2 of 8 times 45, 2/3 of 8 is 16 over 3. Computing RC left is 128.255 kilonewtons upward. Then considering CDE, summation moment D equals 0. So RC right times 4 plus 20 times 1 equals, RC right times 4 plus 20 times 1 equals 129.776 plus the moment of this uniform load 45 times 3, 1.5 plus 1 is 2.5. So RC right is 111.819 kilonewtons. Then adding R sub C is 128.255 plus 111.819, we obtain 240.074 kilonewtons upward. Then problem 11, determine the member force of BD. AE is constant. So I'll make BD as the redundant. This is indeterminate to the first degree. I'll call that Q. Then for the reaction, summation moment about A equals 0. I'm not presenting the solution anymore. That's statics. That's simple. So upward reaction at D times 3 equals 60 times 4 plus 90 times 0. So 60 times 4 divided by 3. This is 80 kilonewtons. Then summation moment D equals 0. Reaction at A times 3 plus 60 times 4 equals 90 times 3. Therefore, reaction at A is 90 times 3 minus 60 times 4 divided by 3. So that's why it's 10. So it checks 10 plus 80 is 90. Then summation versus X, so AX is 60 to the left. So beginning at D, summation forces Y or X. Summation forces X first equals 0, leftward positive. So SAD positive plus horizontal component of Q is Q times 3 over 5 equals 0. So SAD is negative 0.6 Q. Then summation forces vertical equals 0. SCD plus Q times 4 over 5, vertical component of Q, Q times 4 over 5, plus 80 equals 0. So SCD is negative 0.8 Q minus 80. Then we proceed to joint C, summation forces vertical equals 0, downward positive. So we have SAC, vertical component, so SAC times 4 over 5, plus SCD, which is this, negative 0.8 Q minus 80, equals 0. So SAC is equal to Q, then 80 over 0.8 is 100. So Q plus 100. Summation forces X equals 0. So we have 60 equals SBC plus the component of SAC, quantity Q plus 100 times 3/5, horizontal component of SAC. Then SBC is equal to negative 0.6 of Q. Then at B, summation forces vertical first equals 0, downward positive. So we have SAB downward, then plus 90, then plus vertical component of Q times 4 over 5 equals 0. So SAB is negative 0.8 of Q minus 90. So since we have solved all the members here, so let's check equilibrium summation versus X. So SBC, remember SBC is negative 0.6 Q, then plus horizontal component of Q times 3/5, Q times 3/5, so adding equals 0. So it checks. Then we check equilibrium at A. First, summation versus X. SAD is negative 0.6 Q, which is this, plus horizontal component of SAC, so plus quantity SACQ plus 100 times 3/5, then minus 60, then for Q, negative 0.6 Q, then positive 0.6 Q, 0. For the constant, 100 times 3/5 is positive 60, minus 60 is 0. So summation versus X is 0. Then finally, summation for SY, we have 10 plus vertical component of SAC is 100 plus Q times 4/5. Then plus SAB, which is equal to negative zero point 0.8 Q minus 90. So it is also 0. So that means we have analyzed and expressed all these members in terms of the correct expressions and Q. So we tabulate the members in alphabetical order. So AB, SAB is negative zero point 0.8 Q minus 90. So partial derivative of S with respect to Q is negative zero point 0.8. The length of AB is 4 meters, so 4. Then obtain the product, negative zero point 0.8 times negative zero point 0.8 times 4 is 2.56 Q. Then negative 90 times negative zero point 0.8 times 4 is 288. For the second, AC is Q plus 100. The partial derivative of Q plus 100 with respect to Q is 1. The length is 5, square root of 3 square plus 4 squares of 5. Getting the product, it is 5Q plus 500. Next, AD, which is this, negative zero point 0.6Q, derivative negative zero point 0.6, the length is 3, obtain the product 1.08Q. BC is also negative zero point 0.6Q, partial derivative negative zero point 0.6, length 3, product 1.08 of Q. And then BD is simply Q, derivative 1, the length is 5, so product 5Q. S, partial of S with respect to Q times L, that's what I mean by product. Then finally CD, negative zero point 0.8Q minus 80, partial derivative negative zero point 0.8, the length is 4. Obtain the product, it is 2.56Q plus 256. So adding this column here, it is 17.28Q plus 1044. Then summation of S, partial derivative of S with respect to Q over AE is the relative displacement of BD, which is 0 because it is an internal force. Remember, the work done by an internal force is 0. So equating it to 0, divided by AE equals 0. So AE times 0 is still 0. So that means Q is negative 1044 over 17.28. So Q, which is SBD, is negative 60.417 kilonewtons. The negative sign tells us that it is in combustion. So that's it for this video.